In this video, we're going to take two functions. Each one has a fraction in it, so they're two rational functions, and we're going to find the composite function. And we'll do both directions, f of g of x, and in the next slide, we'll do g of f of x. So let's start with f of g of x. Okay, so we know for composite functions that we're taking the output of one function and putting it in as the input of the other. So when we're looking at this order, f of g of x, it means that the output of f of g of x, is going in for the input, which would go here, right, and here into our other function. So let's rewrite that and see what it's going to look like. So that would look like 5 over x over 5 over x plus 7. Okay, so that's our composite function, just not simplified. So now we've got to work on the simplification part of this. So that's usually the hardest part of these. So there's really nothing I can do with the numerator for now, so we're going to leave that like that. Now the denominator, in order for me to get this to be one fraction, which I want to be able to get it as written as one fraction so that I can then keep simplifying, I need a common denominator. So my denominator is going to have to be x. So I have to rewrite this 7 over 1 as a denominator of x, so which means I've got to multiply the top and the bottom by x. So let's see what that will look like. It's going to be 5 over x plus 7x over x. So now at least we have a common denominator on the bottom, so we can rewrite that as one fraction on the bottom, 5 plus 7x over x. So we're getting there now. So now that we were able to do that, now we have a fraction divided by a fraction. So to do a fraction divided by a fraction, we are going to rewrite it as multiplication by the reciprocal. So instead of 5x divided by that whole thing, it's going to be 5x times the reciprocal of that whole piece. So this is the point where I can see if there's anything to cross-reduce. Okay, so I do see that I have an x over x right there. I can cross-reduce. I cannot touch that 5 because it's not a 5 and a 5. It's a 5 and a 5 plus 7x. So I'd only be able to cancel with another 5 plus 7x. So this looks like the best we can do here. If we gather across, multiply across, we get 5 over 5 plus 7x. Again, resist trying to cancel those 5s. They don't cancel. So that's the best I can do for that one. So that would be my f of g of x. So let's see what happens when we do it in the opposite order. Okay, so let's see. Now I've got my two functions again written up top. And now I'm doing the opposite. So I'm taking the output of this one and putting it in here. I think this one's going to be easier, this direction. So let's see. It's going to be rewritten as 5 over just x over x plus 7. Okay, so I look at it really as like this being, that's my whole numerator, that's my whole denominator. So I don't have any two separate fractions that I have to find a common denominator for. So right this point, it's 5 divided by that fraction. So let's rewrite it as 5 times the reciprocal. So it's 5 over 1, if that's helpful, so that you can see both numerators, both denominators. And then, okay, I'll look to cross-reduce, but I don't see anything. Again, you want to resist trying to cancel those x's, because it's not an x and an x. It's an x plus 7 and an x, and those don't cancel each other out. So that I'm just going to multiply across. So I have a couple different ways I can write it. I could keep it like this. Or if I want to distribute and write it as 5x plus 35 over x. Either one of those should be okay, and that would be what let me just try to insert in here, or let's see. That would be my g of f of x equals either one of those. Okay, so hopefully that helps finding the composite function when the two functions given are rational, when they have variables in the denominator and fractions.